Welcome to STEM School. Right, so we're going to do the discriminant of a quadratic equation. A quadratic equation is y equals ax squared plus bx to the power 1 plus cx to the power 0. And this equation can be written as y equals ax squared plus bx plus c, where x to the power 1 is written as x to the power 0 is 1. In order to solve quadratic equation, we have to set y equal to 0. So we set y equal to 0. Ax squared plus bx plus c equal to 0. The solution for this equation is when x is made the subject, and that solution is x equals minus b plus or minus square root b squared minus 4ac over 2a. b squared minus 4ac is called the discriminant. D, because it discriminates what type of quadratic we have, what type of solution. X is called the roots, or roots, because there are two roots you can get, plus or minus, and it's also called solution. So roots are also called solutions. Because b squared minus 4ac equals d, so I'm going to replace here the b squared minus 4ac. Therefore, x will be minus b plus or minus square root d over 2a. That is the discriminant. It determines what sort of roots we get. There are 4 conditions that goes with this d. So there are 4 of them. The first one is when d is positive. So when d is positive, and there are 2 states of when d is positive, so I'm going to draw this. When d is positive, and when d is positive and the value of d is a perfect square, and here not perfect square. When d is a perfect square, it means that quadratic is factorizable. And when d is not a perfect square, it means that quadratic is not factorizable. A perfect square is when you have, say, if d was 4, 4 can be written as 2 squared, therefore d is a perfect square. If d was 9, 9 can be 3 squared, therefore d is a perfect square. Even if d is 1, 1 can be written as 1 squared, so it's a perfect square. Now, when d is positive, you will get 2 roots. When d is positive, you will get 2 different real roots. So the roots that we're talking about will be x equals alpha and x equals beta. That applies to both of these. You will always get 2 roots. And the graph you will get for them, you get 2 roots, but one can be factorizable and the other cannot. And the graph you will get for those roots will be, if you sketch a graph, this is what you will get. When it's positive, the graph will go like that. So that's a positive quadratic. If A is positive, that's if A is positive. And if A is negative, it will be more like that. Still, but the key fact here is you have 2 roots. 2 roots. They're both, when D is positive, you get 2 different real roots, so they're different. X is maybe -4 and x maybe -1. Here will be maybe x equals -2 and x equals 1. So you get 2 distinct roots, real roots. Real means real number. And you'll see why the emphasis on real is important. So the next condition is when d is negative. When d is 0. The next condition is when d equal to 0. D equal to 0 will give 2 same real roots. So you get x equals alpha and you get x equals alpha again. Example might be x equals 3, x equals 3. And the graph for positive A, say look, when x equals 3 would be more like sitting on 3. The quadratic will be sitting on 3, so that'll be 3 there. So it's just touching the x-axis. So you can think of it as coming in, that's one root. It's coming in as one root, and then it's leaving again from that point as a second root. That's your y, and that's your x. I could sketch the same graph with negative a. So this is positive a. Negative a, it will be more like that. That's minus a. Well, that's a is negative. Let's just call that minus 2. X is minus 2. So you will get x equals minus 2, x equals minus 2. It's coming in at minus 2 and then leaving at minus 2. It's coming in at 1 and then leaving at, it's coming in at minus 4 and leaving at minus 1. The third root will be when d is negative. That means d is less than 0. When d is negative, you will get 2 complex roots. So complex root means that 2 non-real roots. You can now see the emphasis on real. The emphasis on real is telling you that these are real numbers, so that's a real number. Integer, that's a real number, or just a number. It doesn't have to be a whole number. It could be a decimal number. That's why it's a real number. But a complex number is a combination of, a complex root is a combination of real and complex. Example will be x equals alpha plus or minus I beta, which is, say, 2, alpha is 2 plus or minus 3i. That's an example. The graph of a complex number, complex root, is parabola that's coming in and doesn't cross the x-axis or touches the x-axis. That's another one here. That's a negative version. That graph is coming in and it does not touch the x-axis. That's a complex root. And the reason, what is I? I is root of minus 1. Just give an example. If I have root of minus 9, that can be written as root minus 1 times 9, which is root minus 1 times root 9, and root 9 is 3. Therefore, I would have 3i, because I is root minus 1. That's where the number comes from. The discriminant, and why they call it discriminant of a quadratic, because it discriminates what type of graph you get. You will get a perfect square if your d is a perfect square. You can factorize the quadratic. It's a good way of checking whether you can factorize a quadratic, because not all quadratic is factorizable. If d is not a perfect square, it's not factorizable. But you will still get 2 real roots in either case. 2 distinct real roots, 2 different real roots. When d equals to 0, you get 2 same real roots. That means a number, no complex number. And that's an example, and that's the type of graph you get, where the graph is touching the x-axis. When d is negative, when that's negative, you will get a complex situation, and that graph does not cross the x-axis. Or it crosses y, but it will not cross the x-axis. Question 1. Find the discriminant of 15 minus x minus 2x squared. How many real roots does the function have? Well, first of all, we need to write the function down in a quadratic way, standard form. A quadratic standard form is ax squared plus bx plus c. And so we need to write that in our quadratic standard form as minus 2x squared. That's the first one, because you write it in the highest exponent. Then you have minus x as the second one, plus 15, that's a plus here, that's the third one, where a equals minus 2, b equals minus 1, and c equals 15. We need to work out d, because it's referring to how many roots we're going to get from this. D will tell us how many roots we get and what type of roots they are. D will be b squared minus 4ac. We need to substitute those values into here, and we get d equals minus 2 squared minus 4 into bracket b is minus 1, so minus 1, not minus 2, minus 1. A is minus 2, open bracket, c is 15. D equals minus 1 squared is minus 1 times minus 1, that's 1 plus 1. Minus 4 times minus 2 is plus 8. 8 times 15 is 120, which implies D equals 121. D is 121. 121 is a perfect square. Therefore, we should be able to factorize that equation, that function, that expression. D is also positive. D is greater than 0. That meant that the function will have two different real roots, and that's what the question is looking for. They want you to show that D is greater than 0, and therefore D will have two different real roots. We're not told to sketch, otherwise it'll be fun to sketch. Question 2. Find the range of values of k for which the function fx equals 3x squared plus 2x plus k has two distinct roots. To have two distinct roots, D has to be greater than 0. And therefore, we need to find D. We know D equals b squared minus 4ac. Therefore, b squared minus 4ac must be greater than 0. B So if we write the coefficients down, A equals 3, B equals 2, and C equals K. If I substitute those values into here, I will get 2 squared minus 4 into bracket A, which is 3, into bracket K, and that should be greater than 0. 4 minus 12K is greater than 0. 4 is greater than 12K, so I just move the 12K to the other side, or just add 12K to both sides of the inequality. Divide both sides by 12. 4 over 12 is greater than 12 over 12K. One over 3 is greater than K. Therefore, K is less than 1 over 3. Just so you know, if 2 is greater than 1, what that meant is 1 is less than 2, right? That's what happened here. Right. The next part, we are to do the same, but the function has one root. That meant it has two roots, same roots, two same roots. That's why it's one root, two same roots. D has to be equal to 0 for that to happen. We know D is B squared minus 4AC has to be equal to 0. That meant 4 minus 12K equal to 0. 4 equals to 12K. Divide both sides by 12. You get 1 over 3 equal to K. Therefore, K equals 1 over 3. The C part has no real roots. That meant D has to be less than 0. 4 minus 12K is less than 0. 4 is less than 12K. 1 over 3 is less than K. Therefore, K is greater than 1 over 3. Question 3. The equation kx squared plus 12x plus 9k equal to 0 has two distinct roots. Find the range of possible values for k. So the clue here is the two distinct roots. Now that is saying that D has to be greater than 0, which means B squared minus 4AC must be greater than 0. From the equation we've got, we know that A equals K, B equals 12, and C equals 9K. So we're going to plug those values here. 12 squared minus 4 bracket K bracket 9K greater than 0. I've just replaced B with 12. That's 144 minus k times k is k squared. 4 times 9 is 36. 36k squared less than, greater than 0. Then I'll move 36k squared to the other side. Or perhaps I might get difference of two squares, because it is difference of two squares. So I'll get 12 squared minus 6k, as you can see, 6k squared is greater than 0. How do I write these two situations? I'll get 12 minus 6k and 12 plus 6k is greater than 0, because we know for difference of two squares, dots, if you have a squared minus b squared, it will be a minus b times a plus b. So that's what difference of two squares is. I can see that here. I can see 36 is 6 squared and k squared is there, so 144 is 12 squared. Now what that meant is I have to say 12 minus 6k is greater than 0, therefore 12 is greater than 6k, therefore divide both sides by 6, I'll get 2 is greater than k. So 2 is greater than k. The other side of the equation, so I set that to greater than 0. I need to set that to greater than 0 too. So that's why I have 12 plus 6k is also greater than 0. Therefore, 12 is greater than minus 6k. Divide both sides by minus 6, because I just need k on its own. I will get minus 2 is greater than, because I'm dividing it by minus, if you divide by minus, you're going to get, you have to reverse your sign. Minus 2 is less than k, because if you divide by minus, you have to reverse your sign. This is good. You just take this and leave it there, and you know 2 is greater than k, so your final answer will be that one as it is. Minus 2 is less than k, and then but k, 2 is greater than k, therefore if 2 is greater than k, what that meant is k is less than 2. That implies k is less than 2. So this is k, it's less than 2. That's your range. That's your beautiful range.